For this activity, we'll be deciding whether to retain or reject the null hypothesis. In addition, we'll also be taking into consideration the effect size. So if you're doing a two-tail hypothesis test, one of the ways is to look at the significance two-tail, and if it's 0.05 or less, then you can reject the null hypothesis. In this case, it being 0.007, we'd be able to reject the null. But if that information wasn't available, we could also look at the z-test. If the z-test is equal to or beyond plus or minus 1.96, then again we can reject the null hypothesis, which in this case, that's clear. The third way, which isn't as obvious in this particular example, is to take a look at the distribution of sample means and to see where the sample mean itself is among them. So our sample mean is shown as a solid yellow circle here, and it's hard to tell exactly how far away it is from the middle. But if it were 1.96 standard errors or more away from the middle, then you could reject the null. You may wonder why this distribution of sample means is so narrow. And the answer is that our sample size, in this case, is 2,830. We almost never work with samples that large. But when you do have a sample of such incredible size, then even in very small and minute differences can be sufficient to reject the null hypothesis. In terms of effect size, there's lots of ways to measure just how big of an effect did the treatment have. Cohen's d is one of those measures. Cohen's d looks at the number of standard deviations between the sample mean and the population mean. So in this case, a Cohen's d of 0.05 means that there's just 0.05 standard deviations, or just 1/20th of a standard deviation difference between the sample mean and the population mean. That's a very small difference, but when you have a sample size of 2,830, that's all you need apparently to reject the null hypothesis in this example. So just because you can reject the null hypothesis doesn't mean that the effect was particularly noteworthy, important, valuable, or something even to write home about. To know that, we have to look at the effect size. So in this case, we could reject the null. There truly is a difference between the sample mean and the null hypothesis, but that difference is so small as to not be particularly noteworthy. In this case, we'll retain the null because the significance is 0.238, which is larger than 0.05. Here again, we're going to be able to reject the null hypothesis, and we have a rather large sample size of 2,437. Our Cohen's d is 0.08, so we're looking at a very small effect size, but we're going to reject it. In this case, our sample size is just 12. When you have a sample size of 12, you have to have a really big effect in order to reject the null hypothesis. We're able to do that. Our significance is 0.001. Looking at the z-test, it's 3.39. That's definitely beyond the plus or minus 1.96. But look at Cohen's d. It's 0.98. That's almost one full standard deviation of difference between the population mean and the sample mean. So when you look at the graph, this solid red is showing us the expected distribution of scores based upon the null hypothesis. Here's our sample mean. Again, it's almost one full standard deviation above where the null hypothesis says that it would be. So we have a large effect size, and we're able to reject the null hypothesis. This is a wonderful and ideal situation. Here we're going to be retaining because our significance two-tail is of 0.921 is greater than 0.05. Here we get to reject. Significance is 0.046. Our Cohen's d is 0.75, so again, we notice a fairly large effect size. When you are seeking to interpret Cohen's d, and there's not much known about that particular area of research, then a general rule of thumb is that a Cohen's d of 0.2 is a weak effect, a Cohen's d of 0.5 is a medium effect, and a Cohen's d of 0.8 or so is considered a large effect. How you going to actually interpret Cohen's d, again, can totally be affected by that area of research, but that's the general rule of thumb there. So this Cohen's d of 0.75 is really large, and so we could say, hey, this is a fairly large effect size here, and we're able to reject the null.